Приветствую всех присоединившихся.
Hi, everyone who joined the session on LLMs. So let's continue. So this block will review a big number of interesting presentations. So we are talking about large language models. Those are the models which help us to help with the text and other consequences and other sequences. And at this session, we are reviewing practical application in the industry. Alyona Fenogenova, AIRI NLP, Experimental System of Machine Learning Department, Executive Director, SberDevices. She will share the information on the benchmarking for Russian language. Andrei Lavrentiev, Physics and Mathematics PhD, Head of Kaspersky Neuromorphic Platform, Predictive Analysis for Anomaly Detection. We'll be talking about neuromorphic AI. Andrei Yevtikov, Chief Data Officer of Sber, will share information on how the leading consumer of suppliers of LLMs and why the future is for cooperation with the customers. Nikolai Zinov, Yandex, DL and NLP, will share the details of the information about Yandex GPT. Michael Salnikov, Scientific Advisor on Computing Semantics from AI Institute, will talk about question-answer systems using graphs and big language models, large language models. Hi, everybody. My name is Alyona Fenogenova. I am NLP SberDevices team. Hi, my name is Denis Dimitrov. I'm Sber AI Data Analysis and Scientific Consultant at AI AIRI Institute. So today we are presenting a new benchmark, MERA, to assess LLMs. Denis, the floor is yours. Thank you, Alyona. So now the problem of data sets, metrics creation is a very burning issue. Why so? Because in the recent several years, even a year, a big number of new models appeared, fundamental included, which thus can solve more and more complicated tasks. And those models can be open source or proprietary, created inside closed companies and used also internally. Also, there are Russian language models we announced this year, GigaChat, Kandinsky, and some other models. And Yandex GPT, also a big LLM announced by Yandex. So moreover, those models become multi-language models and multi-modality models. And there's a problem outstanding: how to assess them and how to compare such models to understand their quality. Roughly speaking, which model is better or worse? So currently, every company actually inside itself has its own benchmark to assess the generative or fundamental. And they think that their benchmark always is better than others, of course, because it's theirs and their metrics are better. And very often inside companies, every team has their own small mini benchmarks. That's a problem, of course, because that does not allow you to honestly compare different models like GigaChat, Yandex GPT, or ChatGPT. Moreover, there's a problem that generative and fundamental models are very difficult to automatically assess because very difficult to find a metric. Example is the fit metric. While it's an error in the distance model, well, very often they use to assess the quality of text models. So this metric is calculated in a different way. Despite one formula, you can calculate it differently with different data sets and with different settings and with different pre-processing of data. And surprisingly, the companies cannot get aligned even in this because everybody calculates their fit differently. That is why it's difficult to compare models, text, and others. And to create single metrics and benchmark is a very burning issue for us to understand whether there is progress in the world or not, and which direction it moves in. Another example to illustrate the problem I talked about. There's a dataset MMLU. It's the dataset or benchmark which was developed by the Berkeley University team. It has 57 domain questions: mathematics, history, computer sciences, and other questions related to legislation, and so on. So all tasks are made up in the multi-choice format, so you have to select the right answer. And for you to select in the right way, the model must not only be able to answer the questions of a very simple type, but also has a common sense. I mean, the general knowledge of the world. Just one example, biological example. Task from MMLU. Well, in the population of out of 400 people, they have cancer because they have this. They are in the Hart-Reinberg. So this proportion containing this recessive gene B with no cancer, and the answers given to solve the questions. The model should be aware of the biology questions because otherwise the answer is not contained in the question. So there's an implementation which is harness, Helm, and the original one which was offered by Face. So here are three implementations. They differ very much. The same data set with different prompts and different bugs in different versions. And importantly, in those options, there are different code bases, different settings, preliminary, and configs that differ, very different, and parameters of generation, and few-shot generations. That's why the different implementations assess the models in a different way. You can look at this table, for instance, in MMLU, in Helm and original, the Llama 65B is the top one. And if you take the harness MMLU, then the top model here is 40B. Even inside one data set, you can see different options, which is no way to go, which is no good. That's why we need a single data set, which will fix and will contain similar scenarios, use the same metrics, and will have similar configs, as we call them, adaptation strategies, like, for instance, prompting, for us to assess the models inside the benchmark in a fair way. And actually, this benchmark cannot be done by any team or company alone. Only having united with the support of different companies, scientific institutions, universities, will we be able to create a cool benchmark recognized by all, where we can assess fundamental language models and fundamental multimodal models, which are beyond the framework of just the language domain and text, with images, sounds, and other modalities, whatever. Well, that's very good that we did make attempts to do it. Russian superglue and other competitions that were multimodal, fusion brain challenges that we did at the AIJ conference this year. By the way, we did have this fusion brain challenge, a strong intelligence 3.0, with a task of with three modalities: images and sounds. Those benchmarks are becoming obsolete, and we will have to develop absolutely new single benchmark to get a huge number of companies involved: Sber, Yandex, and other companies, institutions, FISTAC, Moscow State University. Only together will we be able to create this kind of honest single benchmark with data sets and metrics, single set. And this will allow us to strengthen the reputation, and the goal is to create one recognized in the world. This benchmark should be open, independent, and that's exactly a big number of participants get together creating a benchmark. And this benchmark, as I said, will assess the quality of multimodal and text and language models. Good news here to offer. Back in 2019, alliance of AI was set up, which is functioning, and actually the goal is to unite different corporations, business and universities, science, academia, to do such big projects like benchmark creation and to try to contribute to the common models and also deep learning science. Now I'm giving the floor to Alyona. She's going to talk about our successes in the first attempts, our multi-model MERA, and Alyona will give you details about MERA. So what was put into the MERA and what we wanted to put? First of all, as Denis several times said, that independence and objectivity were important. That is why that was the first criteria that was set there by us. Then before that, we had issued other benchmarks like Russian superglue, tape, rucola, but unfortunately, such benchmarks are obsolete. The majority of the Russian superglue have been solved already. So this benchmark was given the tasks a more complicated level, more complicated reasoning to assess the capabilities of the model, to understand what they can, what they cannot. We can see the trend in fundamental models to interact with the user through the instructions. All modern fundamental models support the instruction-based format. So the MERA benchmark also should support the instruction-based format and conclusions. So we present our task as a set of rules. Thus, we interact through prompts with our models, respectively. Similarly, as we did before with tape benchmark, this benchmark is not designed to fine-tune the models. It is designed for zero and few shot formats to directly through instructions to interact with the models to see what they can and what they cannot do. The current trends show, and we can see the deep finding and OpenAI, that the companies in this or that way pay special attention to safety and ethics of AI. So this benchmark also was put in some websites which do support this kind of assessment. Multimodal track also is very popular, and we can see how the models are developing, and we have to assess the models according to the multimodal setup. The current first version we are announcing will have only text modality in it, but further on we of course are planning to support all this story, adding images and audio, and even in this version of benchmark we already have put the code, mathematics and formal languages. So what's in our new MERA benchmark? 21 tasks in instruction-based different domains, assessing different capabilities of the model and its knowledge. Totally, you can divide the classes of tasks into three big types. First one is problem solving. The tasks that, from the point of view of the existing task, you have to, the model has to solve very complicated one, very complicated reasoning, logics, root cause, cause and effect, and among it, there are some tasks from the previous benchmarks not yet solved by fundamental models, the Russian superglue and tape. Also, we added our new tasks there, which include down to context tasks and also memory and many others. The second big cluster is exams. Well, seemingly how we assess a person using exams after school, because we have to pass the state exams and we have to understand whether the models can do it. This type of tasks takes into account the tests and tasks for special knowledge. Special preparation and training, so it's Russian language state exam and program tasks, different types of codings and others. And number three class is optional. It's diagnostics purely, it's ethics. This class of tasks is not concluded into the total score of benchmarks, so those tasks are needed to fix and identify the biases, they are based on international standards, academia, like ethics, HHA, and detoxification.
Опять же, на экране вы можете...
On the screen, you can see the whole list of our tasks, split by types and formats of the task, and one of the 3 classes available.
Среди примеров...
Among the examples of our new tasks, we can identify RUTAI, which is a Turing test interview emulation. We are trying to create different types of tasks in the format of dialogue for it to remember the context. And there are some references to the dialogue of the model to the first questions, which is quite an interesting thing and shows the capability of the model to perceive the information, identify different other capabilities, and follow the context and what it can remember. Among those tasks, we have our favorite Winograd and its common sense and ethical sets we took from Big Bench, from Google, and Human Eval, which is used in the world to assess the code capabilities of POP. For our benchmark, we created the leaderboard, a separate site where you can get acquainted with all our tasks and load them, and after that try to solve the 21 tasks here using them. For you to run your model on those data sets, you have to use our code, which we provide together with the site and data sets. It will help you to run all models in the fixed format in the equal conditions. After that, the results of the model you can bring it back on the site, and on the site in some time you will see the scoring, and you will see all the numbers for each 21 tasks. Again, in your personal account you can see all those scores and analyze the capabilities of your model, and in the future, if you want to publish, there's the button on the site, and the moment you press the button, your submit goes to the experts, and the experts, in this case, they are the people who are constantly involved in assessing the language models, and they know exactly what it is. So from academia and industry. From industry, it's AI Alliance, and from academia, it's Caltech and Higher School of Economics, Russian Academy of Sciences, and Moscow State University. They will process your submit, your application, to see how honestly and independently all things were done, and if everything is okay, they will publish your results on our dashboard. So what we currently have, 17 tasks plus 4 diagnostics data sets. It's the first version of the benchmarks, which will have this closed test and certain parts of training data for us to assess how your model operates. Along with this, we provide human benchmarks. It's assessment of the human being with the same test for you to have things to compare. And also, for convenience of using, we have sample submissions and some baselines for assessment. And then we are planning to add some generative tasks, which will automatically be scored also, and set prompting, and of course multimodality. So in the next version of benchmarks, we are planning to have images. So we will be happy if you join in our benchmark to participate in creation and new sets. Thank you for your attention.